Again, I welcome you in MT5504, Mathematical Programming, Unit 4, Transportation Problem and Assignment Problem. We are in the transportation problem and we have seen several methods. First of all, we have seen that in which type of equations we are having a solution to the given transportation problem. Also, that is, given transportation problem has a solution if and only uh, the situation that demand is same as supply, and we also have seen that in basis we are having m plus n minus 1 variables. We have seen several methods to get initial basic feasible solution, so-called row minima method, column minima method, table minima method, that is a least cost method, and the Vogel's approximation method. But till now, we haven't verified that any of the method's solution is optimal or not. So today, we will see a stepping stone method in which you will guarantee that our problem is having optimal solution or not, and also we will guarantee means we will if your solution is not optimal, then via that stepping stone method we will reach to the optimal solution. Okay, so I am starting with the problem. So let our problem be as this. Our sources are, as usual, I am taking A, B, and C, and 1, 2, 3, and 4. I am giving as destinations. The transportation table, transportation cost table, I am writing here. So this is the cost table. Values are 2, 11, 10, 3. Oh, sorry, there is one more. 5, and their cost is 7. Then here 1, 4, 7, 2, and 1. Here transportation costs are 3, 9, 4, 8, and 12. Now I will apply first of all Vogel's approximation method to get the initial basic physical solution to which is the closest to our optimal solution as we have seen in previous cases. First of all, I am writing the demands and supplies. So supplies are here 4, 8, and 9. Here it is demands are 3, 3, 4, 5, and 6. Okay, so I am now starting with the Vogel's approximation method to get the initial basic physical solution. So first of all, I will go for minimum of 2 and 3. So minimum of 2 and 3, that is 1. Difference is 1, minimum is 1 and 1, so difference is 0. Here minimum is 3 and 4, so minimum is difference is 1. Here 1 and 2 are minimum, so difference is 1, 4 and 9, so difference is 5. Here 4 and 7, so difference is 3. 2 and 3, so difference is 1. 1 and 7, so difference is 6. So the maximum value is 6. So corresponding columns, the minimum is 1. So we will allocate whatever the maximum possible, that is 6 here. And here I am left with 2 and here I am left with 0. Then again we will continue the same process. And for the Vogel's approximation method, this is 0, so corresponding column is now removed. So again minimum is 2 and 3, so difference is 1, minimum is 1 and 2, so difference is 1, minimum of 3 and this row is 3 and 4, so difference is 1, here columns difference will not be changed, so it is 1, here 4 and 5, here 4 and 7, so 3, and here 2 and 3, so 1. Okay. Now maximum is 5, so corresponding columns is fixed. Now here minimum is 4, so we will allocate whatever is maximum possible, that is 2. So here we are left with 0 and here we are left with 1. So 2 is the allocation. Now this row is now cancelled. So we are having this table remain with these two rows only. So minimum of 2 and 3, that is 1, minimum of 4 and 3, that is difference is 1, minimum is 2 and 3, so difference is 1, 9 and 11, so difference is 2, 4 and 10, so difference is 6, 3 and 5, 8, so difference is 5. So maximum is 6, so we will select this column and their minimum is 4, so we will allocate whatever is maximum possible, that is 4 and for 9 possibility is 4, so we will allocate 4 here, so here we are left with 0 and here we are left with 5. So this column is now removed. Now again we will continue. Here we are having 2 and 3's difference is 1, 3 and 8's difference is 5, 2 and 3's difference is 1, 9 and 11's difference is 2, and 3 and 8's difference is 5. 5 and 5 there is tie, and again in the minimum also we are having a tie, that is 3 and 3, here maximum possibility is 5, 4 and here maximum possibility is 3. You can go for this 4 or 3. I am right now choosing this 3, okay, intentionally. So here I am left with 2, here I am left with 0, so this column is removed. Now I am having this 4 entries left, so again difference is 9 and 11, that is 2, here difference is 5, here difference of 3 and 11, that is 8, and here difference of 9 and 8, that is 1. So 8 is maximum, so corresponding minimum is 3. So I will allocate whatever is possible, that is here I am writing 4. Here I am left with 0 and here I am left with 1. You can see if we have started 3 4 there, then we will, in next loop we will reach here 3. Okay, so this is the reason I was planning to explain you that either you can choose and at the optimal solution you will reach to the same solution. That's why I have made this. So now this row is cancelled and we are left with only this row. So here values are 1 and 1 possible, that is 1 and 1. So here we are left with 0, 0 and here 0. Okay, so this is our solution via Vogel's approximation method. I am keeping only this much part because this is enough to explain whatever is our final situation. So I am keeping just this allocated table and the allocation values with me. Rest I am not keeping with me. So I am keeping this and pasting it here so I can get as. So this is my table and I am removing the unnecessary stuff. Okay, so this is my situation means allocation. So that actually says that from B to 2 I am transferring 2 unit, from B to 5 I am transferring 6 unit, from A to 4 I am transferring 4 units, from C to 1 I am transferring 1 unit, from C to 2 I am transferring 1 unit, from C to 4 I am transferring 1 unit, from C to 3 I am transferring 4 unit, and so this is our allocation. If you want the values written with here, you can directly sum of this and you will get that. So I am not giving that. I am giving this one table with me. Now I want to identify that this solution is optimal or not. So the best thing is if I want to check that this is optimal or not. Here, for example, here we are not transporting anything. If I want to transport any, all we are having possibility things are we can allocate from any of the cell to get another solution. Okay, so I am planning to allocate something here. So I am feeling that if I will allocate something here, means I will transport anything from here, or everything is I am taking integer, so I am right now keeping as integer. So let me write 1 unit. I am transporting 1 unit from here. All I want is sum to be 4. So all to make this sum 4, this is already 4, so I have to subtract 1 unit from here. Okay. And if I want, I am subtracting 1 unit from here, I have to add 1 unit of here because I want to sum this to 5. And I have already subtracted 1 unit here, so I have to sum this one. Also, I have added 1 here, so I have to subtract 1 unit from here also. And since subtracted from 1 here and added 1 here, so this is complete. You can think it as a loop also. See here, this loop is like this way. What we have done from non-allocated cell, we have started a loop. We reached to the allocated cell, and then we have changed the direction. We have reached to the another allocated cell. Then again we have changed the direction. We have reached to the another cell, and then changed the direction and we move back to the original cell. So this is called loop. What is the transportation cost differences that we have to calculate? See, if we are transporting in this way, all the other cells allocation transportation cost is not going to be changed. Only the change will be in this, and this cell. So only the transportation cost going to be changed via these 4 cells. So we will calculate only the change in the transportation cost due to this. Okay. So if I am transporting from A to 1, then the corresponding transportation cost change will be here. If you are transporting 1 unit, then the transportation cost will be 2 times 1, that is 2 plus. Here I have reduced 1 unit transportation. So minus 1 times 3. So minus 3 plus I have added transportation cost here. But because I am transporting 1 unit more from here, I am getting one extra transportation cost, that is 8, and I am removing 1 unit transportation from here. So here it will be reduced cost by 3, that is minus 3. So the total transportation, if you will transport 1 unit from A to 1, then in these situations it will be affected by this much unit, 10 minus 6, that is 4. Means we will pay extra 4 rupees in transportation. So transporting from A to 1 in this situation is not supposed to be done. Okay, so that is not a very good way to transport from A to 1. Okay, so A to 1's transportation is not allowed right now. It may be happen in next situation it is allowed. Let me handle this in way. Okay, so what I am trying, let me copy this so I can keep this for me wherever I will require. Okay, now I am doing is the checking of the transportation cost if I will transport from A to 2. Means now I am planning to transport via this point. So if I want to transport 1 unit from this, then of course as the previous situation, to sum this thing for, I have to subtract 1 unit from here. I have to add 1 unit here, and since I am adding 1 here and adding 1 here, so let me remove 1 unit from here. So this sum will be remain 3, this sum will be remain 4, this sum is remain 4 plus 3, 7, 8, 9. So this sum will be continued to be 9. Okay, if I will do this. So in that case, I am having this as a loop. So if I will transport from A to 2, then the corresponding extra transportation cost is here. The transportation cost was 11. So 11 times 1 plus minus 1 times 3. So minus 3 plus 1 times 8, that is 8, plus minus 1 times 9, so minus 9. So here it is minus 1 minus 4, so here it will be 7. So additional transportation cost is 7, means transporting from A to 2 is also not preferred to do. Okay, now A to 3 is already there. Means already we are transporting from A to 2. So that is not the better way to do calculate for that. Okay. So now I am calculating for A to 5. So if I am transporting from here, means A to 5, then to if I am transferring 1 unit from here, then from here to to sum this 6, we have to subtract 1 unit here. To sum this 8, we have to add now 1 unit here. To sum this as the previous situation, means 3, if I have added 1, so I have to subtract 1 unit here. If I am subtracting 1 unit here, see here also, or I have added 1 here, so I have to subtract 1 unit here. If I have subtracted 1 unit here, I have to add 1 unit here, and since here it is subtracted, this is added, so everything is clear. See, at the final situation here, 4 minus 1 plus 1, it is 4, 2 plus 1 plus 6 minus 1. Okay, so here 2 plus 6 8, and here plus 1 minus 1, so it is cancelled, plus 1 minus 1 cancelled, plus 1 minus 1 cancelled, plus 1 minus 1 cancelled. So our loop in this case is this way, from here to here, 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 and then here. Okay, so the additional transportation cost on doing this is 1 times 7, so 7, 1 times 1, that is minus 1, then 1 times 4, so it is plus 4, minus 1 times 9, so it is minus 9, 1 plus 1 times 8, so it is plus 8, then from A, here it is minus 1 times 3, so it is minus 3, and then that. So we are having 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay. So we are having 7 plus minus 1, so it is 6. Sorry, minus 5 plus 5, so it is 6. So additional transportation cost on transporting 1 unit from A to 5 is extra 6 rupees. So this is not preferable. Okay, means we cannot transport from A to 5 any additional thing. Similarly, we will continue for each and every point. Now for B, we will calculate that from A to anywhere transporting except for is not preferable right now. Now similarly, we will do that. Is it possible to transport from B to 1, B to 3, B to 5? B25 is what it is. So B21, B23 and B24. Then C25. Yeah. And then we'll check that actually which one is preferable solution to our given system. Okay. So now here we are in this situation. Again in B we will calculate. So here if we are transporting 1 unit, then we have to subtract 1 unit here to make sum these three. Now I am adding, subtracting 1 unit here and adding 1 unit here. So here minus 1 plus 1, so it is cancelled. Minus 1 plus 1 cancel, minus 1 plus 1 cancel, minus 1 plus 1 cancel. So transporting from B to 1, the additional transportation cost is here 1 times 1, that is 1, minus 1 times 4, so it is minus 4, 1 times 9, so it is plus 9, and minus 1 times 3, so it is minus 3, so here it is 5 minus 3, so 2 plus 1, so it is 3. Okay, here it is minus 3, 6, okay, 3. So additional transportation cost on transporting from B to 1 is 3, so we cannot go for that. So that is not a preferable situation right now for us. Do the similar for B to 3. So for B to 3, if I am transporting 1 unit from here, I have to subtract 1 unit here, add 1 unit here, and subtract 1 unit here to balance the situation. So in that case, transporting from B to 3, the additional transportation cost is here 1 times 7, so that is 7. Here minus 1 times 4, so it is minus 4. 1 times 9, so it is plus 9. And minus 1 times 4, so it is minus 4. So here it is 1 plus 1, so it is 8. So additional transportation cost is 8. So we cannot go for transporting from B to 3. So that is also not allowed. Now we make another loop to transport from B to 4. So B to 4, if I am transporting 1 unit from here, I have to subtract 1 unit here, then plus 1 unit here and minus 1 unit here, so I can get balance. And make sure via that triangularization of bases, this loop, what we are finding, so here we are adding, then subtracting, adding, subtracting, and adding, that will be always unique because of the choice of this triangularization of basis here. Okay, so this loop is unique. And I have selected here minus 1, but if you will go for minus 1 here, you are not able to balance the things. So that's why I have added subtracted 1 minus 1 here. Okay, so here now I am having minus 1, plus 1 and so on. So the additional transportation cost is here minus 1 times 4, so it is minus 4, 1 times 2, so it is plus 2, minus 1 times 8 is minus 8, and plus 1 times 9, so it is plus 9. So here it is 1, and here it is minus 2 plus 1, so it is minus 1. So transporting 1 unit from B to 4 is advisable because it is reducing the cost. Again, let calculate that 1 times 2, 1 minus 1 times 8, 1 times 9, and minus 1 times 4. So here it is minus 2 and here it is 1, so minus 1. So this is advisable to transport 1 unit from B to 4. Okay. But it may happen that transporting from this place may get more additional reduction on the transportation cost. So let me calculate for that point also. So the only last thing is remain. So we will calculate here also. So if I am adding transporting from this point, then means C to 5. In that case, here it is plus 1. So I have to sub minus 1 here, then plus 1 here, and minus 1 here to get the balance. So in this case, we are having additional transportation cost is 1 times 4, so it is 4, minus 1 times 1, so it is minus 1, 1 times 12, so it is plus 12, and minus 1 times 9, so it is minus 9. That is, here it is 3 plus 3, so 6. So here also we are getting that extra transportation cost, so we are not transferring from here. So the only very good situation is to transport from B to 4. Okay. If we are having negative multiple answers, see here also if we are having minus 8 and here also we are having minus 10, in that case we will go for most negative. Okay, so here I am having only one, so I am choosing that one, so I will transport whatever is maximum possible transaction from B to 4. So what is the maximum possible transaction? If I go for minus 2 unit here, then here minus 2, then I have to subtract minus 2 here, and that is not possible because as I have said, this triangularization of basis theorem, we are having only one loop exist in this way. Loop is starting from non-basic point, means point where there is no allocation already done. From that we will go towards the all cells which are allocated, and wherever we will go, we will change the direction. Means here we are coming in this direction lower, then we will change direction here and then here and so on. We are skipping this. Okay, we are not moving towards this table, this cell. So from here I am directly jumping here. Okay, so why you may ask that why we have changed the direction from this point, but that is only because we have skipped this column, because you can jump. Third column is not preferred to be third. It may be second and second and first, third. So anyhow, that is the loop. So all whatever from negative cells, whatever is the minimum that will be changed. So here my situation is this one. So let me copy this so I can continue with that table. Okay, now here I am having um, this as a preferred loop. From the negative corners, whatever is minimum, that will be uh, transported from one place to another. So here we are transporting. So from negative, minimum is 1. So I will transport 1 unit, exactly 1 unit here. We will subtract here, so it will be now 0. So there is no need to calculate it. Now this is subtracted, so now this is replaced by 1, and this is 1 plus 1, so it is 2. Okay, so my next table is like this one. Let me write it just directly. This is now 0, so I am removing from there, and then change the values I am writing directly here, so you can see. So new changed values are here, this value is 1 because 2 minus 1 it is 1. Here I have added 1. Here this is 0, so I have removed, and here it was 1 plus 1, so it is 2. See, previous case and this case same, sums are same. Here it is 4, so here it is also 4. Here it was 4 plus 6 plus 2, it is 8. Here it is 6 plus 1 it is 8. Here it was 3 plus 2 plus 4 plus 0. Sorry, 4. Here 3 plus 1 plus 4 plus 1. So that is 4 plus 4, 8 plus 9. And here also it is same. See, it is 3 plus 2, 5 plus 4, 9. Also for the column we are having same. Here it was 3. Here it is also 3. Here 2 plus 1, 3. Here it is also 2 plus 1, 3. Here 4 plus 0. So it is 4. 1. Here it was 4, 1. So here it is also 4, 1. And here it is 6, 0. So here it is again 6, 0. So we are in the new solution to the given transportation problem. So this is the iteration we used to do in the simplex method or dual simplex method or any. Okay, if you can solve by transportation problem by simplex method, okay, there is no problem, but all the constraints are of the equality type. So you will have m plus n artificial variables, and here in this case you will have pi plus 3. So 8 artificial variables. So there your table will be large and the process will continue for longer time. So that's why I am not preferring that method. Okay, and this method is better. And this method is here we have checked via this cycle process that we this our solution is optimal or not, and that is this method is called stepping stone method. Okay, so this via which loop we are doing this, that is this method is called stepping stone method. To identify that our given solution is optimal or not, and if it is not optimal, then via that loop, whatever loop is giving you negative, via that loop you can move towards the optimal solution. But you cannot guarantee that this is our optimal solution. Okay, so all you have to do is again apply the stepping stone method to check that this solution is optimal or not. That application of stepping stone method in continuing this will be done in the next lecture. So till that, stay at home and stay safe. Thank you. I will continue with the same problem and at this stage in the next lecture. Thank you.